Hey guys, today we are going to take a look at the graphs of the cosecant and the secant functions. So remember, cosecant is the reciprocal of sine, secant is the reciprocal of cosine. So what we're going to do is I'm going to use these two graphs to show you how to make these two graphs. Okay, so for example, the first one, the cosecant. So cosecant is the reciprocal of sine. So what I'm going to do is I'm going to draw a normal sine graph from 0 to 2 pi. So I'm going to start at the origin. I'm going to go up to 1, its high point. I'm going to come back down to the x-axis, down to -1, and then back to the x-axis. So I'm going to draw this out, but I'm going to draw it with like a dotted line because this isn't really part of our graph. It's just a tool we're going to use to draw our graph. So here's my sine graph. I could make a second cycle going this way, so I could keep this going down and back up. So there's 2 cycles. Now, let's think about what it means to be a reciprocal and what kind of values that means that we would get. So for example, look at this point right here. For this value for pi, sine equals 0. Well, the reciprocal of 0 would be undefined. So every place that we have an x-intercept, the cosecant function is going to have a vertical asymptote. It's going to have a value that's undefined. So that's the first thing we do. All of our x-intercepts, we go through and we draw these little vertical asymptotes. So these are going to be lines that our graph is not allowed to cross. Our graph is just going to head towards them and then follow them. All right, let me look at another point that is easy to think about. So this right here, this would be 1. Okay, well, the reciprocal of 1 is also 1. So this point right here, and this point -1, and this point +1, those are going to be parts of our graph of our cosecant because they're reciprocals, and so that point's going to be on our graph. But then think about this point right here. Okay, whatever this angle is, it'd be pi over 4. Okay, you go up about a half. Actually, I guess pi over 6 would be up about a half. So think about the reciprocal of 1/2. Well, that'd be 2. So our graph goes up towards 2. And then this value down here, let's say this is 1/4. Well, the reciprocal of that would be 4. And then the reciprocal of 1/10 would be 10, and so on and so forth. So as this graph, as our sine graph, is heading towards 0, our graph is heading towards infinity. So it's going to curl up that way. Same thing's going to happen on this. This little downward hill, our graph is going to curl up. And so we're going to get this little parabola shape that's trapped between our vertical asymptotes. Same thing's going to happen down here. So all of these negative values, when you do the reciprocal, they're still negative. They're just going to be curling downward towards infinity. Same here. And the same here. So that would be 2 cycles of a cosecant. These 2 together would be 1 cycle, and these 2 together are another cycle. Okay, so the easiest part, the range. So domain and range. The easy one is the range. So this arrow is headed towards -infinity, and then the graph goes up to -1, and then it stops. So our graph goes from parentheses, -infinity to -1, bracket, and then there's no values here. There's no cosecant values. And then the graph starts at 1 and heads towards infinity. So that's the graph of the cosecant function. That's the range. The domain would be all real numbers except where these vertical asymptotes are. Okay, those are values that are not in our domain. So the easiest way to say that would be x cannot equal. So let's start with 0. That's an easy place to start. And then pi, 2 pi, -pi, -2 pi, any multiple of pi, there's another vertical asymptote. So x cannot equal 0 plus any multiple of pi. That would be the domain of the cosecant function. Okay, so knowing that, this graph of the secant function. So secant is a reciprocal of cosine. So I'm going to do the same thing. I'm going to draw a cosine graph. I'm going to start at the high point, x-axis, low point, back to the x-axis, and the high point. I could do a second cycle going this way. And then I'm going to make a, like I said, I'm going to make a dotted line out of this. Just like our vertical asymptotes are dotted lines, this isn't really part of our graph. It's just a tool we're using to draw the graph. Okay, so that's the first thing I do. Then I go through all my x-intercepts. I'm going to make vertical asymptotes because my graph is going to have vertical asymptotes. And then focus on this little downward hill right here. This part is going to have a graph going curling down and down. Notice the cosine graph goes up and kind of stops at its high point. So what's going to happen to our secant function? It's going to have that same high point, except it's going to be a low point for our graph. And then we're going to reflect just this little half. So we're going to have like a half of a parabola over here. And then we're going to have a half of a parabola over here. That is one cycle of a secant graph. Now, I could complete the cycle, and so I'd have kind of an entire looking parabola right here. But I just want you to see this is what one cycle would look like, where you have these two little half, part of the graphs over here and part of the graphs over here, and you got this low point down here. Okay, same range, everything from negative infinity to negative 1. And then everything from positive 1 to infinity. And then the domain, again, any place we have a vertical asymptote is a place we're not allowed to put into our domain. So like pi over 2. All you need is a starting point. So pi over 2 plus, and then again, every time you add pi, you land on another vertical asymptote. So any multiple of pi, that's the domain. So we're just listing where our vertical asymptotes are. Okay? All right, so let's try to graph some functions that are going to have some transformations in them. So I'm going to do A and B, and then I'm going to see if you can do this other A and B for, examples on your own. So first one, just like all the other graphs, amplitude. We need to know what our amplitude is. In this case, it's 2. Our period, same period, 2 pi over 2, so that would be pi. And let's see, there's no phase shift, there's no vertical shift, so that's all we need to be aware of. So I'm going to draw, I'm going to make my x-axis, go out to pi, I'll cut that in half and cut that into quarters. This is a cosecant graph. Cosecant is the reciprocal of sine, so I need to think about that the whole time. So that's what I'm really going to graph. I'm going to graph a sine graph with an amplitude of 2. So I'm going to start at the origin. I'm going to go up, back down, down and back up. So that's the first thing I do. There's my sine graph. I could draw a second cycle this way. So I could keep going down, back up and back down. So there's 2 cycles of my sine graph. And all these x-intercepts are going to become vertical asymptotes. And then I'm just going to take all these little hills and I'm going to invert them. So this is going to go up and up. This little part's going to get flipped and it's going to go down and down. And then the same thing over here. So the solid line, and you could either do solid lines, you could change colored pencils or something to kind of make this pop out so you can tell what the actual graph is. Okay? Again, for this one, now because of that amplitude, our range is going to change a little bit. And our domain, so our domain is still x cannot equal 0 plus, okay, so this is pi over 2. Every half pi, we're landing on another asymptote. So pi over 2, k. And then our range is everything from negative infinity up to negative 2. And then there's a big gap, and then it's everything from 2 to infinity. So negative infinity to negative 2. And 2 to infinity. Okay, and that's our range. And that's our cosecant graph. The one beneath it is a secant. Okay, so again, I am thinking cosine. That's what I'm going to graph. This one, let's see, amplitude is 3, but this one's going to get flipped because of that negative sign. My period is going to be 2 pi divided by pi over 2, but if I multiply that by this thing's reciprocal, I'm going to get a 4. So this graph is going to go out to 4, cut it in half, cut it into quarters. I'm also going to go to negative 4, cut it in half, cut it into quarters. Amplitude is 3, so I'm going to go up to 3, I'm going to go down to 3, but this is where I'm going to start. I'm going to graph a cosine graph that has been flipped. So I'm going to start at its low point. I'm going to go up to the high point, back down, and back down. So this is my cosine graph. I'm going to draw a second cycle going this way. So up, down, and down. All of my x-intercepts are now vertical asymptotes for my graph. I'm going to take this hill right here, invert it into a parabola. Same thing on this other side. This low point is going to go that way. Now this is just a little half of a parabola, so it's just going to go, that's that little half where my secant ends, and then I'm going to do the same thing over here. Again, domain, every place I have a vertical asymptote, so I need a starting asymptote. So looks like 1. Okay, so x cannot equal 1. And let's see, the next one is at 3. So if you add 2, and then I have negative 1. So if I subtract 2, if I subtract another 2, so any multiple of the number 2, that's where my vertical asymptotes are. And then the range, well, the range is everything from negative infinity up to negative 3, and then everything from 3 to infinity. Okay, now I want you to try example A and example B. So a couple things to think about. Cosecant, that's going to be the reciprocal of sine, so that's what you're going to graph. Notice this one has a phase shift. Okay, so remember, this graph is going to get shifted the opposite of this value right here. So your graph is going to get shifted left pi over 2. Now you're not going to know what pi over 2 looks like until you make your x-axis. Okay, but that's a little hint there. And then this one down here is going to have a vertical shift, that little +2 on the end. So one of the first things you're going to do once you draw your graph is you're going to go up 2 and then create a midline there. So I'm just going to, just a couple hints, and then I'm going to let you try to graph those. All right, so this is what your final graph should look like. So this one had an amplitude of -2. I ended up with a period of 2 pi, and there's that phase shift I was talking about. So this graph, -2, it went down first. This was the first cycle of my sine graph, and so this right here would be the first cycle of that cosecant. So make sure it's been shifted to the left slightly. And then example B, this was secant, so I was going to draw a cosine. Amplitude was 1. The period was 3, so there's me going out to 3. And then I shifted up 2, and there's my midline. Okay, so I drew my cosine graph, and then I used that to draw my secant.